So this is my video on section 3.1, which is on quadratic functions. Now we did quadratic equations before. We actually learned how to solve a quadratic equation using three methods. But now we are actually looking at it as a function. So the only difference is that we do have the equation, but now we are thinking of it as a function where there's an input x and this is the output. So quadratic, of course, is a function where the degree is 2, right? And it's of the form x squared plus bx plus c. So so this is heavily applied in real life, and a simple example would be if you throw a ball into the air, and if you want to model the height of the ball after at a certain time, that's a quadratic function. And most of the profit functions, if you look at profit will go up and come down, and then you have break-even points and maximum profit, right? So there are a lot of applications in real life on quadratic functions. So let's try to see how we can sketch a quadratic function. Let's go right away to the steps involved. So in order to sketch a quadratic function, first of all, you need to uh, to uh, to uh, to convert this quadratic function into what is known as the standard form. And by the way, there are two types of quadratic functions. There is one which is like a bowl, and the other which is like a dome. And the shape is determined by whether the leading coefficient, which is the coefficient of x squared, whether that is positive or negative. If that is positive, then it's a bowl, and if it is negative, then it's a dome. So if you're trying to find the least cost, then we are looking at something like a is greater than 0. On the other hand, if you're looking at a profit curve, then we're looking at something where the leading coefficient is negative. Okay, so going back to what we are trying to do here. So the first step of this process is we need to convert the quadratic function into what is known as the standard form. Okay, and then we are going to use, I will explain what the standard form is later, and then we are going to use transformations. Now, when we did section 2.5, we learned how to create new graphs from old graphs by using vertical shifts, horizontal shifts, and then stretches and compressions, right? Okay, so first we are going to convert this into the standard form, and then we are going to use x squared as our catalog curve, right? And then use transformations to go get there, because any quadratic can actually be converted into another quadratic using the catalog curve x squared and the transformations. All right, so first of all, let's start with an example. So the idea is to first convert this into the standard form and then to sketch. So now, what is the standard form? The standard form is actually of a quadratic function, is a form which looks like this. I want you to pay careful attention to that. What does it look like? It has a number a and then another square plus another number. So it doesn't have a x term. It has only a square term times a plus k. Now this one actually has an x term, so it's not in the standard form. So we need to convert this into this form. And really what we need to do is we need to complete the square. Now we already know how to complete the square. We learned in section 1, right? Chapter 1, we learned that, right? And then so we will complete the square by doing what we do, right? Okay, so this is our function, right? And we want to complete the square. So if you remember how we did that, we took the middle term and we divided that by 2, and then we get something, and then whatever that we get, we square it, right? So 4 divided by 2 is 2, and then 2 squared is 4, and we add that to both sides. So we add 4 to the left side, we add 4 to the right side, and when we add the 4 to the right side, we add it so that it is close to the x term, and there's a reason for that. And then after we add it, there's still this 5 which is outside. Okay, so now we have y plus 4, and the reason why we did that is that when we look at the first 3 terms now, that is a square. Okay, and what square is that? So we put a placeholder, and the first number of the square is the first number here, which is x. Then the sign is the sign which is here. Second number of the square is half of the middle term, which is 2. So we have a square, and that is a square plus the 5 is still there. Now we need to solve for y. So if you need to solve for y, we need to subtract 4 from both sides, and when we subtract 4 from this side, we get y. When we subtract 4 from this side, we get 1. So now if you look at it, this is in the standard form. Y. Y is there, compare y to y, and there is no x term now. There is a x plus 2 squared, which is like this. So what is a? A is like 1, and h is like what? -2. Later on we will know that actually, and then k is like 1. Later on we will see that these actually correspond to the vertex of the quadratic function or the parabola, right? But for the time being, this is now in standard form. Okay, x plus 2 squared plus 1. So now how do we draw this? First of all, we have the catalog curve y equals x squared, and then we just how do you draw? You just take about 3 guide points. 0 goes to 0, 1 goes to 1, 2 goes to 4. So 1 if you plug in, you get 1 squared 1. 2 if you plug in, you get 2 squared, which is equal to 4. And the guide is this. And then what we do is we want to get x plus 2 squared, right? So in order to do that, that's an internal shift to the left. So we shift everything to the left, and then we get this. And then finally we need to shift it up by 1, and then we get the red curve, which is the final curve that we want. So you can see that by using our catalog curve x squared, because this is in the standard form, we can now use some kind of a shifting, right, and maybe some stretching or compression, right, okay, and to get it into get the graph that we want. Okay, so that's how we draw a quadratic function. What you do is you first bring this, you start with the function, bring it into standard form by completing the square, and then you use transformations, right? And this is a much more neater figure of this. So this is the original x squared, and this is the blue curve is the x plus 2 squared, which is shifted to the left, and this is the final, the green curve is the final one, right, which is x plus squared plus 1. Okay, so now let's do another one. Okay, so now this is another example. We need to convert it into standard form and sketch. So this is a very almost sure question for the final exam. So I want you to get used to this converting to standard form and sketching. So now there's a difference here, because here again you complete the square, but then this is slightly more complicated, because before you do anything, you need to make sure that the coefficient of x squared is 1. So how do you do that? You divide out by 2. Well, there are several ways of doing that. I'm going to just explain one way of doing it. Divide out by 2, and then you get x squared. When you divide this by 2, you get 4x. When you divide this by 2, you get 7 halves. And then what you do is you take half of the middle term, which is 2. As usual, you square that, and you get 4 again. And then you add 4 to both sides. So you add 4 to this side, and you add 4 to this side, and when you add it to the right side, you make sure that you add it next to the 4x, so that you get a square. And then you have just 7 halves on the outside, and then this is a square. And what's the square of this? So x is the x, and sine is a sine. And what is the second term? And that is half of 4, which is 2, and that's the square, plus 7 over 2. And then you want to solve for y. So first you take the 4 over to that side. So when you take the 4 over to that side, you get x plus 2 squared minus 7 plus 2 minus 4. So you take the common denominator for that, which is 2. So you take 2, you get 7 minus 2 times 4 is 8. And so y plus 2 is still there, is equal to x plus 2 squared minus 1 half. And then if you multiply by, you need to solve for y. So multiply by 2, you get 2x plus 2 squared minus 1 half times 2, which is 1. Okay. So now if we start with the catalogs, you will see that the catalog x squared is shifted to the left by 2, right, and then multiplied by 2, right, and then subtracted by 1. So there is a horizontal shift of 2, and then a stretch by 2, right? Okay, and then a minus 1, which is a vertical shift down scale. So we start with the red is the catalog curve. So now you can see that the blue curve is actually the horizontal shift. The green curve is actually the stretch, which is the stretch by 2. And then finally the purple curve is a final curve. So once again, you can see that you can get any quadratic function. You can draw the graph by first completing the square and getting it into standard form, and then using stretching to get the answer. Stretching and whatever compression, shifting, transformations in general. All right, so we'll stop this video for the time being, and then I will continue with how to find maximum minimum in another video. That's it for now. So thank you for watching this video.